Go ahead. Welcome everyone. Welcome back. This is the second part of 6.3, where we're gonna run through 5 examples today just to practice. Okay. So this one, it says to rewrite the quadratic function below in standard form. So remember, in standard form, we have to split this up, right? The x plus 7. How do we expand x plus 7? Quantity squared. You guys remember? Yeah. It's going to be x squared plus 2 times 7 is 14 times x is 14x plus the last term squared. So 7 squared is 49, right? And then dropping down the rest, minus 5. And then here, I am going to distribute out the negative, right, to all 3 things. So then that's negative x squared plus 14x, or minus 14x, minus 49 minus 5 equals y. So y would equal negative x squared minus 14x minus 54, right? And that would be your answer. Okay? So just going through those steps will get you from vertex form to standard form. All right? So this one is another one, right? Rewrite the quadratic function below in standard form. Okay, so if we start off there, x plus 1 quantity squared breaks out to be x squared plus 2x plus 1, dropping down the 5, the plus 6 equals y. Again, I'm going to distribute out the negative, right, to all 3 things. So that's 5x squared plus 10x plus 5, and then the plus 6 comes down, equals y comes down. So y would equal, gathering the like terms, 5x squared plus 10x plus 11. And that would be my standard form there. Cool? Yeah? So please remember from our previous set of notes, the special forms. Okay? All right. My next example, it says to find the coordinates of the vertex of the following parabola algebraically, write your answer as a coordinate. Okay, so we have that. Remember, when we're trying to find the vertex, we have to first find our axis of symmetry. And remember, our axis of symmetry formula is negative b over 2a, right? So here, if I get my a will always be the coefficient of x squared. My b will always be the coefficient of my variable x, and my c value will always be the constant. Okay? And I know that we're not going to use c during this whole process, but I want you guys to get used to getting c. Okay? Because we are going to use that later on. So negative b is negative 32 over 2 times negative 2, which is my a value. So here we have negative times a negative is a positive, so positive 32 over 2 times -2 is -4. 32 divided by -4 is -8, right? So my axis of symmetry, ooh, I forgot x equals. My axis of symmetry is x equals that. So my axis of symmetry is x equals -8, right? And along with my axis of symmetry being x equals -8, I also got the x value of my vertex. Okay, so I'm halfway there. -8 comma blank, right? Yeah. And here, what I need to do is figure out what my y is. And my y, I get it if I plug in -8 back into my function. Okay, so f of -8, which equals y, which equals -2 times -8 squared minus 32 times -8 minus 144. Right, going back with my purple pen. Okay. So this is y equals -2 times 64 minus or plus, because 32, -32 times -8 is positive 256 minus 144. 64 times -2, that would be -128 plus 256 minus 144. And so y is going to equal, if you do that math, -16. Okay. So my vertex is going to be -8 comma -16. All right. Cool. Yeah. Any questions here? So whenever we have an equation in standard form, we can figure out our vertex at the very least, right? Let's do that here as well. Okay. Let's do that here. We're going to graph the equation y equals x squared plus 10x plus 16 on the accompanying set of axes. You must plot 5 points, including the roots and vertex. We're not going to do the roots today, right? In this lesson, right? In this module, we're not going to take the roots. In our next module, we're going to learn how to figure out our roots, but not in this module. Okay? So we're just going to graph it, including our vertex. Okay? We need 5 points. Okay? So here, let's figure out our vertex. Okay? So here, my A value is 1. My B value is 10. My C value is 16. So my axis of symmetry is going to be x equals -b over 2a, which is x is equal to -10 over 2 times 1, which is 2. That's -5, right? So my vertex is going to be -5, comma blank. So again, to get the blank, we need to get f of -5 equals -5 squared plus 10 times -5. plus 16. Okay. -5, -5. That's 25 minus 50 plus 16. So f of -5 equals -9. So I have my vertex at -5, comma, -9. Now what we just did in our previous example. Okay. Any questions on that process? Okay. Once we get our vertex, we can graph this using transformations or algebra. I'm going to show you guys both in this example, okay? So first, using algebra. If I set up a table of values, x and y, this is -5, comma, -9, right? I am just gonna pick x values that are 1 away from the vertex and 2 away from the vertex. Okay, going in one direction. All right. So using algebra, and my equation is y equals x squared plus 10x plus 16. Right, double checking that. Yeah. Okay. I'm gonna plug in f of -4. Just like how I plugged in f of -5, right? Do the same thing. So this would be -4 squared plus 10 times -4 plus 16, right? And if I do that, simplify that math, this would be 16 minus 40 plus 16. That would be -8. So f of -4 equals -8. So my y value is -8. Okay? Make sense? Yeah, if we just plug it in. Do the same thing with -3. Find f of -3. So that would be -3 squared plus 10 times -3 plus 16. Okay? And if we do that math, this would be 9 minus 30 plus 16. That would be f of -3 would be -5. Okay? So this would be -5, right? So if I graph this, -5, -9, that's my vertex, right? -4 and -8 is right here. -3, -5 is right here. Right? So I have one side of my parabola. Okay? To figure out the other side, I am going to use the axis of symmetry. Remember, the axis of symmetry is x equals -5, right? So it's that vertical line right there. Yeah? And since this point at -4 is 1 unit away, right? Zooming in, go 1 unit away this way is that point, right? This point here, 2 units away, so go 2 units away is that point. And now we got our other side of this, okay? And then if you want to finish out the chart, it would be -6, and -7. And we would have the same y values as their mirror. Right? Cool? And that's using algebra. Okay? Now let's talk about, let me add a page, right? Let's talk about our vertex form. Remember, our vertex form is y equals a times x minus h quantity squared plus k, right? Where h comma k is your vertex. In vertex form or in transformations, what does my a do? What does this value do to the graph if you had to describe it using transformations? My a is a what? Stretch or compress. Vertical, right? It's a vertical stretch or compress, correct? Yeah. Vertical stretch or compress. Yeah. Okay. So if I have an a value up here of 1, remember it's ax squared, right? Yeah. So my a value is 1. So if it's 1, does it have a vertical stretch or compress? No, right? There is no transformation like that, right? This parabola is not vertically stretched or compressed. So if I take my table of values and I just want the table. And I drop it down. Remember my parent function of y equals x squared and that table of values? And if I draw it here, right next to it, remember my table of values is -2, -1, 0, 1, 2. And that would be 4, 1, 0, 1, 2, or 1, 4. Right? Yeah. That's the parent chart, right? Parent points, correct? So we already established that there is no vertical stretch or compress, right? So if that's the case, then from 0 to 1, it's +1, right? So from -9 +1, that should have the same relationship. And it does. -9 goes to -8, right? From 0 to 4, it's a +4. So this should have the same relationship. Does that make sense? Yeah? Because there's no stretching involved, right? In this, there's no stretching, there's no compressing. So that relationship between the two values should stay the same. Yeah? Okay, and vice going the other direction, that's a +1, right? This has to be a +1, +4. So this is also +4. Okay, when my a value is 1, we can do this. All right, cool. Yeah, and granted, my x values is all separated by 1 unit, right? Yeah, -2, -1, 0, 1, 2, and -3, -4, -5, -6, -7. They're all just 1 unit apart. Okay. All right. So both ways work, right? If you like the algebra way, do the algebra way. If you like this way, go ahead and do that. Okay? But in this way, I'm going to write it really big. My A value needs to equal 1 in order to use this way. All right? If it's 2 or 3 or 4, another number, then the algebra way would be better. All right? We can figure it out using transformation. It's a little more difficult. All right? That's the lesson for today, class. Thank you very much.